Hi everybody, this is the activity we did in class, or the worksheet called the Earth, Sun, and Moon Movement, a North Polar view. And on this worksheet you have a picture of an initial Earth position and Sun and Moon position, and you can see it right here. And what you're going to be asked to do is just redraw these three things, and with the Earth, that arrow is important as well. We want to redraw these three things to show the elapsed times that you can see here and on the back of this. So let me give you an idea of what we're talking about here. Here is not nearly to scale representation of the position of the Sun, Moon, and the Earth that starts at this same point. Now what we want to think about is some movement times. We know that one revolution of the Earth is the time it takes for the Earth to go all the way around the Sun and for us to have a year. And that takes 365 days to have that much movement. And we also know that the Moon is orbiting around the Earth in its revolution, and that takes about a month. We're going to get the exact time a little later. And we also know that the Earth, and it's the only one whose rotation we're going to be worrying about now. The Moon does rotate, as does the Sun. But this little mark on the Moon here represents this little arrow, and it can show the rotation. Now, what we want to do is kind of think about how much these move in certain periods of time. So let's say I said, what does this look like after only 12 hours has gone by? Well, if it takes 365 days for the Earth to go once around the Sun, in 12 hours, technically this is going to move, but it's going to move so little, it's literally going to be imperceptible. So that your drawing's really not going to change much. Also, we know it takes about a month for the Moon to go around the Earth, and 12 hours isn't much of a month. So the Moon will move a little bit, but it again, like the Earth's movement around the Sun, is going to be pretty imperceptible. However, the Earth rotates once every 24 hours. So if 12 hours goes by, we will notice a change in that, and we need to just move this so that the spot here, or the arrow on your drawing, is now facing away, showing that we've had 1/2 of a rotation of the Earth, because a full rotation is 24 hours, and so 12 hours will be 1/2 of that rotation. So if I was to ask you to draw this model right here after 12 hours elapsed, it is not going to look much different except for this little spot on the Earth, because 12 hours is not that much time. Okay, let's go back to our original position. Let's say that I said 1 day later. Okay, 1 day later, again, this takes 365 days to go around. 1 day we are going to have some movement, but it's going to be pretty imperceptible. We're not going to move this because it's rotated 1 day all the way around back to its position. The Moon, though, takes about 30 days, about a month, we found out, to make one revolution around the Earth. So in 1 day, this is going to move a little bit, but not much. You know, you have to think of this broken into 30 pieces and how much that would be. So it, again, looks very much like this, but in 1 day, we want to move this just slightly this way. And remember, we want to think about, from a North Polar view, all of this is happening in a counterclockwise fashion. Okay? Now, if we have a little bit bigger amount of time, let's say a week. In a week, again, the Earth takes 52 weeks for the Earth to go around the Sun. So the Earth is going to move a little bit in a week, but again, not much. Okay? The Moon, though, in a week, remember it takes a month, and a week is about 1/4 of that. The Moon now is going to move to this position right here. Now we have a pretty substantial movement in terms of the Moon to the Earth, not a whole lot of movement in terms of the Earth to the Sun. So that's what these are all getting at, is redrawing and making a new drawing with circles that have S for the Sun, M for the Moon, and E for Earth, along with that little pointer on it that shows how these would be arranged during these different amounts of time passages. Okay, let's just try one more. let's go back to our original position. There we are. And now let's do one that's, say, a month later. Now, after a month later, now the moon, remember we have 12 months in a year. So if you think of this like a clock with numbers on the phase of a clock, although we're going to go counterclockwise, this is going to move from the 6 o'clock position to the 5 o'clock position. So we do have a pretty reasonable movement of the Earth, at least noticeable, over a 1 month time. But the moon goes right like this because in a month, it's done a full, roughly, revolution around the Earth, and it's kind of back to this starting position. So what you're doing on all of these is you're redrawing these bodies according to the elapsed time written. And I've just given you a number of examples here, and now you need to do them on your own. But remember, moon around the Earth, revolution, about a month. Rotation of the Earth, one time around in 24 hours. Revolution of the Earth around the sun, 365 days or 52 weeks. Okay? So, happy Earth, Sun, and Moon movement North Polar view drawings.